Welcome to the Logic videos. I'm Scott Aikin. These are videos for the Philosophy 3003 Formal Logic class at Vanderbilt University in the spring of 2021. This is the first video, Logic Basics number 1. What I'll do in this video is I'll talk about these 5 issues. I'll talk about arguments, talk about formal logic about arguments, I'll talk about the types tokens distinction, I'll talk about 2 programs in logic, and then I'll talk about some areas in logic as a field. What we do in logic is we study arguments. That's, you might say, an express statement of reasoning. What we're trying to do is identify how our explicit reasoning is good. And whenever some is good and some is bad. And not just to discover when it's good, but also to explain what's good about it and what's bad about it. So let's start with a definition of an argument. An argument is a set of claims or a set of propositions with 2 subsets: premises and conclusions. Premises are the claims that we use to reason from. They offer support for the conclusions. Conclusions are the propositions that we reason to. So arguments in some ways are a collection of propositions with 2 subsets that have a functional relation. Some that you reason from and some that you reason to. So what we're trying to do whenever we evaluate arguments is we're trying to evaluate whether or not that function of argument is successful. And one of the things that we do in natural language to identify whenever we've done that, whenever we think that we've done that at least, is we have very special words in our natural language that identify those distinct functional features of arguments. We say things like therefore, hence, and so. Those words play a role between the sentences. Otherwise, it's just a collection of sentences and you can't tell the difference and you don't know what's happening. In natural language, we identify that functional relation between those 2 subsets of propositions in an argument with little indicators, conclusion indicators, inference indicators. So hence we'll say, here comes a conclusion. Because is something that says what was I said previously was a conclusion, and what comes next is going to be a premise. Since works that way too. That will say A since B. You're saying that I'm reasoning from B to A. So what we have then in natural language are indicators that show this functional relation between these 2 sets of propositions. Sometimes you can have lots of premises and 1 conclusion. Sometimes you can have lots of premises and 1 conclusion. Sometimes you can have lots of 1 premise and lots of conclusions. Some premises are just rich. What's important is for us to be able to identify whenever that functional relation is functioning correctly. So that's what we're doing whenever we study logic, is try to identify all the ways that that functional relation can go well and not go well. With formal logic, is that we're looking at a specific subset of those functional relations, a specific subset of, you might say, multiply repeatable forms of reasoning that are really pretty good. So let's look at a couple examples. Let's imagine that I've got a friend. She's either at the bar or she's at home. So if she's at the bar or she's at home, let's imagine that I stop at the bar to see if she's there, and she's not at the bar. So if I know that she's at the bar or she's at home, and I know that she's at the bar, I know something. I know that she's at home. Now, that's a pretty cool little bit of reasoning that we just did there. She's at the bar, she's at home. She's not at the bar, so she's at home. Now let's look at another instance of some good reasoning. Let's imagine that you've got a friend, and your friend had the soup or had the salad. Now, you know this about your friend because those are the only 2 things on the menu at lunch, and this person went to the place with those 2 things on the menu at lunch. And you know, because they didn't come back with a soup stain on their tie, that they didn't have the soup. What do you know? Well, you know that they had the salad. Now, what's important to see is that we were reasoning about two very different things. We were reasoning about where your friend is here and a couple of varieties of where she could be, and we were able to get here. And in this case, we were reasoning about lunch. We're reasoning about massively different things, but the reasoning takes the same form. And it's these repeatable forms that we're going to be looking at in formal logic. And these forms come in all sorts of shapes and sizes and things like that. And the crucial thing with formal logic is that we're doing a couple things. What we're doing is we're looking at these forms, and on the one hand, we're seeing A, that they're right, and B, why they're right. Explaining what exactly is behind them to explain how that works. Here's another one that's very simple. Let's imagine that we're reasoning about some cat named Luna. She's my cat. So we'd say something like, all cats are mammals. Luna is a cat. So we know that Luna's mammal. Right? Now, again, the thought here is that we could do the same thing with all sorts of other things. We could say something like, all Vandy students are humans. Sammy is a Vandy student. So Sammy is human. Now, the crucial thing is that, again, we're reasoning about cats and mammalhood. Here we're reasoning about Vandy students and being a human being. In both cases, though, despite the fact that we're reasoning about massively different things, the reasoning takes the same form. And it's important to see in both of these cases, both in the sort of the either or not and the all, this one is an instance of the all class, and then so part of the predicate class of that claim, those forms are repeatable. And so what we're trying to do with formal logic is look at how all these forms are showing up. There's so many of them. They're all over the place, and they repeat. And they repeat with different stuff about different stuff, but the forms repeat regardless of whatever kind of stuff we're talking about. It's sometimes called the form-content distinction, that the forms repeat and can be repeated in all sorts of different places and with different kinds of reasoning about different stuff. And so what we're trying to do with formal logic is we're trying to do two things. On the one hand, we're trying to detect. So program one, this is the sort of the two programs issue. The two programs issue is that on the one hand, we're trying to detect good forms. And we're trying to detect a whole lot of instances where these forms can all be strung up. So on the one hand, it's a detection program. It's something where once you learn some logic, then you can go out and you can say, like, okay, I've got a bunch of reasoning. I'm going to see if it takes some of these forms. Once I know that these forms are good, I can say, okay, that reasoning is good. Okay, so it's a detection program. You learn the forms, you learn how they get strung up together, and then you can go out into the world and sort of sort good reasoning from bad reasoning in terms of whether or not it fits the forms. That's awesome. But here's another thing. And one of the interesting things about formal logic is that what we're doing is we're also trying to explain. So on the one hand, we have a detection program. What we're trying to do is identify good forms whenever we look at reasoning, but we're also looking to explain what's good in the reasoning. What exactly is it about this form in particular that makes it good reasoning? And so let's go with this one, and we'll look at the two of them. So in this case, we've got, so what was it, bar or home, not at the bar, so home. What we're doing whenever we sort of arrange these arguments this way, by the way, these are called argument schemes. We put our premises on the top, we get a little slash there, and then we get our conclusion at the bottom. Same thing here. We get some premises at the top, we get a little slash to identify the functional relation between those claims, and then we get the conclusion here at the bottom. Now, the important thing to see about this one is that there's a kind of a funny and a really important thing about this word right there. That word is a big important word. All is a big word, right? And so it's all of these. Now, the challenge is that if you're just talking about cats and things like that, and you're just using the word all, it's really hard to explain what's right about this reasoning. We say, okay, if someone was like, look, I don't quite follow, how's this an awesome bit of reasoning? You can just be, it seems like all you'd be able to do if you didn't know the language of logic is being able to sort of pull up and say, oh, right, oh. And you're like, what, you don't know what the word all means? The same thing goes with or here, which is B or H, not B, so H. Bar or home, not bar, so home. And so in some ways, what these kinds of arguments, this kind of argument does is it kind of gives you two options and takes one away and says this is the one that's left. What we're trying to do with logic is try to explain, kind of get behind what looks like it's an obvious piece of reasoning that doesn't need to be explained. But what we're trying to do with logic is we're trying to master all of these little bits of obvious reasoning that we do and integrate them. Make it so that this piece of reasoning is explained by the same kind of stuff that explains why this is good reasoning. And all of the other forms. That they're obvious is not yet enough to make it systematic. What makes them systematic is the deep explanation that explains all of them in terms of one kind of system. So what we're trying to do is, on the one hand, detect good reasoning, but we're also trying to give an explanation for what makes the reasoning good. And so it's also an explanatory program. Now, we'll be talking a little bit about how that explanatory program works, but what's important at this stage is to be able to realize that what we're doing is we're detecting certain kinds of forms. And so here's a little way to kind of appreciate this idea behind formal logic. And it's with this question: how many letters are inside this box? And there are really two answers to that question. One answer, and two good answers. One answer is that there's only one letter inside that box, A. There's also another good answer, which is that there are three letters inside that box, three A's. Now, what's important to be able to distinguish here is between types and tokens. There's one type of letter in this box, which is the letter A. And you can have lots of tokens of A, but for it to still be the same letter, A. So, how many letters are in this box? One type, three tokens. Types are universals, they're multiply realizable, they show up in lots and lots of instances. What's a token? Instances of types. So, three tokens, one type. Now, the crucial thing to be able to see here is that what we're doing, whenever we had the soup or salad, not soup so salad, bar or home, not bar so home, those were all of the same type of argument, a multiply realizable universal form of argument. This or that, not this, so that. That argument shows up in lots and lots of different tokens about various different kinds of things. It's a multiply realizable form, and so as a consequence, what we're trying to do is that we're not reasoning about salad or soup, we're not talking about your restaurant order, we're not talking about your friend's barfly habits. We're not talking about any of these other sorts of things. We're not talking about cats or mammals. We're not talking about any of that stuff. What we're talking about whenever we talk about logic is what makes those forms good. That's the objective that we've got with the logic. And then you can take that and apply it wherever you want to be able to apply it. Shows up whenever you think about cats, shows up when you think about where your friends at the bar, shows up whenever you're reasoning about what somebody ordered for lunch, shows up whenever you reason about the gross national product of Finland, whatever. Those forms show up and are valid regardless of whatever you're reasoning about. Why? Because reasoning that takes those forms are always going to be good bits of reasoning. Now that's interesting, and that's a very powerful thought. And that's what makes formal logic really important. It makes it really powerful. It's the fact that formal logic is able to sort of take these forms, pull them up out of the instances, look at them and see that they're going to always be good. And you can then find them in the good places, and be able to see that. The second piece of that is that once we are able to explain how those forms work, we see lots of other different kinds of forms that are good, and we can integrate them, make them into a system of reasoning, make it not just of being able to test good reasoning, but to use it to explore information. Once we've mastered logic, once we've mastered all of those things that seem obvious and synthesize them, we can use them to be able to explore the information that we've got. That's also a really powerful tool. So the areas of logic, once we've kind of seen how formal logic works, once we've seen exactly the sort of the objectives that we've got with formal logic, let's talk about just sort of certain kinds of areas that we've got in logic. Now, on the one hand, we've got certain kinds of programs of being able to develop ways for us to prove things. So you might say developments of proof methods. So and that's a really interesting program. What we do is we say, okay, well look, we got a couple things that look like they're good pieces of reasoning. Are there ways that we can be able to integrate them into other standing ways that we've been able to prove things, and find ways to make it so that we can show that they're good reasoning? So these are sometimes called developments of proof methods of logic. Another domain is to be able to develop where we can say, like, look, here I'm identifying some reasoning that looks like it's really good reasoning, but I'm having a hard time being able to explain how it's good reasoning. So as a consequence, we've got a certain kinds of puzzles with regards to logic, which is that sometimes we get perfectly good reasoning that takes us to crazy places. That's paradoxes. That's some kind of philosophy of logic. We've got other reasoning where it's not entirely clear to us how it's good, how that works. So you might say we've got these kind of speculative, philosophical elements of logic. We're asking ourselves the question, how's this work? Is this good reasoning? It doesn't look like it fits any of the models that we've got before. Do we need to expand our conception of good reasoning, or do we need to be able to explain what goes wrong here? Those are sort of crazy little puzzles. And again, we'll look at a couple versions of these with some paradoxes that we've got once we sort of learn a little bit more logic. The last area is applications. And in philosophical, and you might say applications of logic, one places that we might take it is into places where we argue, where we go and we say, okay, look, we've got a ton of argument in this place. How can the tools that we've got in logic be able to come in and sort things out? How can the tools of logic come in here and to be able to, at the very least, yield some light? How can the tools of logic come in here and just be another method that can, you might say, yield a little bit more, yield another kind of conclusion? And so the applications here are ones that you might say find all sorts of just interesting new ways that once we've got this tool, finding ways for, again, because we see that the forms are multiply realizable, we can take them into new places and to be able to see what kinds of new products get produced whenever we come in there and start sorting things out with our logic. Next time, what we'll be talking about. So we'll talk a little bit more about the sort of the formal features of logic, and so that'll be Logic Basics 2. See you later.